Hello Finxters. Today we're going to look at sorting one list based on values from another list within Python. And we'll be using a number of tools to do that. We'll introduce the Python zip and sorted methods for carrying this out. We'll also step through a very long multi-step process using those methods, and then we'll show you a concise one-line solution which just makes it a little bit more tidy and more Pythonic. We'll also use the dictionary data type to join and sort our lists, and there's a few caveats with that we'll discuss. And then we will speak around the Python iter tools and the third-party more iter tools function, which will allow us a very concise and Pythonic way of resolving this issue, and that will bring us to an end of this video. So the problem we're going to solve today is we're going to assume that we have a list of stock items, and you see the food items there, and we have carried out a stock count. So we have another list where, for instance, escargot we have 12, nori we have 5, and what we need to do is we need a list of stock items that are sorted beginning with the lowest quantities and finishing with the highest quantities. So we'll run through a few methods of doing that, and the first will be to use the zip function. And if those of you who are watching this haven't used the zip function before, effectively it takes a number of iterables, as many as you wish, and it literally zips them together. So if you have a look here on the screen, you have one tuple A, which has got a whole list of letters in it, B, C, and we're going to zip these together. Now, when you zip something together, it will take the 0 index of the first tuple, it will take the 0 index of the second tuple, and the 0 index of the third tuple, and it will put it into a tuple. And it will do the same for the 1 index, and then it'll do the same for the 2 index, and it'll carry on. Bearing in mind that it will only do to the shortest list. So if your lists are different lengths, it will stop when it reaches the end of the shortest list. So we do zip ABC in this instance. Now when you zip something, it returns a zip object, so we need to use list on it to actually be able to print it. And we pass that to X, and when we print X, there you see we have a list of 1, 2, 3, 4, 5 tuples, and those items are within there. And then we can just use a for loop to clean the zipped list up, and the result is, of course, Finxter Academy. So that's the zip function. It's a very useful function, and we're going to use it today to do a number of our solutions to our problem. The other is the sorted function, and sorted is particularly useful in that it will take an iterable, and this, of course, with all the letters and numbers in it, and we apply sorted to it and print that, and it will give us 1, 2, 3, 4, 5, 6, A, B, C, D, E, F from the original list. So it's a very nice and concise way of sorting an iterable. So we're going to apply those to our problem today. So let's go across and do some coding. And there you see the same stock items. You see the stock count. There's the problem identified. And we do exactly what you saw just now on the PowerPoint presentation. We've asked it to zip the two lists together. Now note that we've put the stock count first because we're going to sort on that number. We need a sorted list that gives us from the lowest stock count to the highest stock count. So we've asked for the stock count first, and we've asked for the stock item second, and we pass that zipped file to zipped list, And as I said, that returns a zip object. So if we were to print that, you would just see what's on the screen there, zip object, and it will give you the memory location. But we carry on. So then we apply the sorted command to that zipped list. And having sorted that list, we pass it to that variable sorted list. And if we were to print that, we would see, once again, a list of tuples with 3 falafel, 4 haikeko, and so on up the list. So we've achieved what we needed in terms of joining the list, sorting the list, and then we simply need to run a little bit of code to take that sorted list, and we're asking for value 1 of each tuple. So that's 0, that's 1, it'll return value 1 from each tuple, and we will end up with our desired response. So let's just run that now. And there you see it. So falafel, aikako, nori, the same as there, but simply what we wanted, which was the list of stock items. So we've achieved what we were after, but that's a fairly laborious process, I'm sure you agree. So we've got 4 lines of code to do what we needed. Now there's a much easier way, of course, that we can put that into a single line of code. So let's just go up to the next, which is exactly the same problem, exactly the same lists. And all we've done is we've put the stock count, stock items into zip. We've passed that to sorted. And then we've just run a little bit of code that says, and I'd like to talk a little bit here about the underscore. Now, normally, if we were going to iterate through a list, we would ask for stock count, comma, stock items in that list. But we don't really care about the stock count. So I've put an underscore in there. And the underscore is used for many things in Python. One of them is the I don't care method, which simply says, I don't really want to know about that. You have to have something in there, so it's effectively a placeholder. Think of it in that way. So you're asking for stock items, for stock count stock items in that sorted list, and you're going to print that. So let's just run that. And there you see the same response down the bottom, but of course in much more concise code format than the one we saw previously. But I think to step through it in the way we did is quite useful because it helps you understand what's going on. You start with the first one, come to the second, and you'll get a much greater appreciation of what is happening. And bear in mind, of course, I've put the square bracket notation in there to return a list. So there's other ways we can do this. I'm going to show you one using dictionary. Now, I'm not for 1 second suggesting that this is necessarily the best way. In fact, I would suggest it's probably not. But I don't know your use case, and maybe it will work for you. So we can do a dictionary sort. The thing with a dictionary sort is that, or a dictionary, is that you cannot have duplicate keys. Those of you who know about dictionary know that we have key value pairs. And so, for instance, we would want to have stock count 12 as the key, and we want to have escargot as the value. And that's fine. 5 is the key, nori as the value. But if, for instance, we had escargot and nori both had 5, we would get an error. It would not, well, no, actually we wouldn't get an error. What would happen would be the dictionary would actually exclude one of those items. So you'd only end up with one of them. You'd end up with either escargot or nori, depending on how the program ran. And we don't need that. But in this case, we only have specific numbers. There are no duplicates. So this will work. At the end of this, I'll tell you a little bit about what to do if you are in the situation where you have duplicates in there. So what we want to do is we want to join the 2 lists as a dictionary. So we have the curly bracket notation, and we're asking for stock count, the iterable from stock count, colon, stock items iterable for I in range, length, stock items. So it's very simple notation. We're asking it to iterate through the lists and just put, first of all, the 12 for the stock count, the escargot for the stock item, the 5 for the stock count, the nori for the stock item, and do that for the entire length of that list and pass that to new dict. And of course, there you see the return. It does exactly that. There's your key, there's your value, and it runs through for the whole list. We then pass that through to this line of code here. And what we're doing here is we're going to do a sort. So we're sorting the new dictionary items, and we're going to sort on item 0. Remembering, of course, that item 0 is the key and item 1 is the value. So we're asking it to sort from lowest to highest in this case, and we're saying that we want that returned as a key colon value for key value in that sorted list, and we pass it to another variable, sort dictionary. And then finally we can print that with the list format. We just want the value, so we want the value for KV in that sorted dictionary items. And if we now run that, once again you'll see it's done. Now once again, I'm not suggesting that this is the best way to solve this problem, but I think it's really useful to understand different ways of addressing an issue, and as I said, your use case may be different. Now, one thing or a couple of things we can probably speak about here. One is, obviously we wanted 0 because we wanted sorted on the number. If you put 1 in there, obviously you get a very different list. If you remember, it's falafel, ikako, etc. If I sort that on 1, then it sorts it alphabetically on the value, which is not what we want in this case. So we can take that back to 0. The other thing to consider is if you do have similar or exactly the same keys in stock count, you have a few 5s, a few 8s, a few 18s, you can use dictionary to do this, but it requires you to go and get a collections module from Python, use the default dict method, and I started writing that, and it is just so complicated compared to some of these other methods that we're using. It's simply not worth discussing here. You just wouldn't want to do it for such a simple result. But if you had a complex requirement where you needed to do that, I would suggest you look at the collections module and the default dict. And in the article, I have actually placed some links to that, so you can go and do some reading if you're interested in understanding. It's a great coding challenge. I enjoyed doing it, and it might be something you wish to try. But certainly this is not the most concise or easy way of doing it. We're going to move to that right now, which is to iter-tools. And so in Python, there is a module called iter-tools. It's a really, really good module to explore. I have put the link in the article. This allows some quite complex calculations to be carried out on iterables in a very, very memory efficient way. There is a third-party solution which is called more iter-tools, and that's the one we're going to use today. I've also put that link in the article. So what we've done here is from more iter-tools import sort together, and sort together is the method we're going to use today, and as you'll see, it is just the most concise way of solving this problem. So we have the same stock items, we have the same stock counts, and all we do is we ask it to sort together, square bracket notation because we want a list, stock count, comma, stock items, and we want to sort on number 1 index. And if I clear this and we run this now, there you see the response. So I think you'll agree using the ITA tools is a very nice, concise way of doing this. However, if you just want to do it from within Python, I would suggest that the zip and sort one-liner is also quite a tidy way of managing this. And just in case you're wondering why I use such a strange way of showing this with all the international foods, I had to have a way of understanding that each method worked when I wrote this. So just to show you how it works for me, if you haven't already worked it out, we'll add a few more lines of code here and we'll run this. And it obviously responds with Finxter. So the first letter of each one of those, falafel, aikako, nori, will spell out the word Finxter. And that was my solution for knowing that each method worked without having to laboriously go through each list. So just going back to the slides to summarize. So in summary, today we introduced the sort and zip functions, and we use those functions to create a list where we took one list and sorted it by the contents of another list. We looked at using the dictionary data type to achieve a similar result, what's often called the decorate, sort and undecorate method. And if anyone's interested in that, you can look up Schwartzian transformation or look up decorate, sort, undecorate online. It's a really interesting method that was developed in the 90s. Perhaps a little bit old hat for what we're doing now, but still interesting if you wish to understand the basics of some of these problems. And then finally, we introduced ITA tools, which is a Python module, and more ITA tools, which is a third-party module, which provided a really neat solution to our problem. So I hope that helped, and thank you very much for listening, and I look forward to seeing you in the next video. Goodbye.